Hi, if you're watching this video, you're watching my video on water quality and management. In this video, we're going to be talking about how we can manage water so that it stays drinkable. In previous lessons, we talked about the importance of water and how little of it is actually available for us to drink. And we talked about how the majority of water is undrinkable because it's too salty, right? So, what is water quality? The quality of drinking water depends on what can be found in it. Do we see bacteria? What kind of minerals are there? Right? If there's too much bacteria in your water, you could get sick. If there are certain minerals in water, it could be poisonous. And so understanding the quality of water is very important as to knowing what is drinkable and what is not. Two common minerals found in fresh water is magnesium and calcium. If there's too much of these minerals, we call it hard water. Now it's not ice, it's called hard water because over time this calcium or magnesium can sort of form this sort of crusty sort of surface over old pipes. Now, if you live near a source of hard water, if the water hasn't been filtered completely out of minerals, which a lot of places don't because those minerals, you need those in your body. And so drinking water can put those in your body and you need them. You can probably see this crust form around your faucet or around your shower heads if you don't regularly clean them. And that's because of hard water. This calcium, this magnesium is sort of drying and staying on as the water evaporates. So as this faucet gets wet, water will evaporate out and the magnesium and calcium will be left behind, creating this sort of crust. Effects of hard water. Having some hard water in our water supply, having some minerals in our water is okay because our bodies can take them in, but too many minerals in the water can damage pipes, damage faucets, and damage fixtures, right? So as this is happening, right, the water is going to flow through a smaller and smaller surface as more and more minerals build up. And if you recall about pressure, well, if water is being pushed through at the same amount of force but through a smaller hole, that pressure increases and increases. It can cause pipes to crack. And so it can actually damage our faucets. So it's not that it's dangerous in terms of drinking it, but dangerous or damaging to our homes and pipes. Where do these minerals come from? Well, as before freshwater makes it to our taps, it's traveled down rivers and streams. And as water flows, it picks up minerals. This is the same reason why the ocean is so salty, right? As rivers flow into the ocean, those minerals get deposited into the ocean. Well, as water is brought into our taps, right, through our pipes, they're picking up some minerals and bringing those minerals through our pipes. And so that creates hard water. Water that does not have a lot of minerals is called soft water, right? So hard water has minerals, soft water, not so much. Humans regularly interact with water in many ways that don't involve drinking, right? We do need it for drink, but we use water for many other things. So pause the video and think about, well, how do we use water other than drinking? Hopefully you paused the video and thought about it for a couple of minutes. Well, we use water in farming, medicine, pesticides, soap, right? Cleaning. So we use water in many different ways, and that can input a lot of pollutants into the water, right? A lot of pollutants made by humans enter rivers, and the runoff can spread these chemicals, such as heavy metals or sewage, into oceans and lakes and other bodies of water, right? So we use water in many different ways, and those ways can result in adding pollutants to that water, and those pollutants can flow back into the oceans and rivers. Natural pollutants, right? Natural pollutants are chemicals that can appear in nature. For example, in farming, farmers use a lot of fertilizer. And fertilizer has a lot of potassium and nitrogen. Well, potassium and nitrogen exist in nature, right? But too much of it can be considered a pollutant. So a natural pollutant could be considered fertilizer. Unnatural pollutants are where chemicals that don't normally appear in nature show up in our water. And this can be this can cause toxicity to appear in the water, or toxicity to rise in the water, right? For example, mercury is an example of an unnatural pollutant. Mercury is a type of liquid metal that can show up in our water when we use it to process things. And as a result, this mercury can appear in the oceans, and they can appear in our fish. And so the fish can become toxic because of the fact that they have mercury in their bodies. So an example of natural pollutants could be fertilizer, and an example of unnatural pollutants could be things like mercury. Natural pollutants. So again, these types of pollutants are chemicals that exist in nature. And adding too much of a certain type of nutrients can damage the ecosystem. For example, wasted fertilizer, which again, as you recall, has natural pollutants such as a lot of phosphorus, potassium, and nitrogen, can enter lakes. Well, algae, which is a type of plant-like organism that lives in lakes, they use those nutrients to exist, to live, to survive. And adding too much fertilizer can cause them to, quote-unquote, bloom. And when they bloom, they create this immense green sort of swath across the Great Lakes. And this is called an algal bloom. This uncontrolled growth of algae is called an algal bloom. And this can damage and irreparably damage the ecosystem found in these Great Lakes because they input too much oxygen into the environment because, again, they're a plant and they use photosynthesis. And that can affect the animals and other plants that exist in that environment. Unnatural pollutants, such as chemicals used to make circuits called PCB, can enter water systems and can make life toxic make water too toxic for other life and human consumptions. And so adding these chemicals to water when we make circuits and other things can make the water toxic. And as they're reintroduced to rivers and lakes and oceans, they can make the water toxic for other forms of life, or make it too toxic to consume or drink, reducing the limited supply of fresh water we have. Scientists look for certain things when it comes to managing drinking water, right? They look for acidity, they look for temperature, oxygen, color, nutrients, bacteria, right? If your water's too acidic, it's not good for you. If it's too warm, it can cause bacteria to grow. If there's not enough oxygen, again, other types of bacteria and other things can grow in it. Nutrients in the water, right? Minerals and such. And the color of the water, is it too dirty? And so scientists study water and water supplies to determine whether or not this water is drinkable. Again, water is a precious resource, and understanding where drinkable water can be found is important for our survival as well as other living things' survival. So scientists use things called bioindicators. Bioindicators are living things that scientists use to indicate the quality of water. Certain insects, such as beetles, caddisflies, larvae, and dragonfly, can only live in certain clean water. It needs to be a certain cleanliness for these types of living things to survive. And so scientists call these bioindicators because if they start to disappear, that means the water's quality is starting to diminish or starting to lower. And if the water's quality starts to lower, these animals start to die off and you don't find them. And so scientists will take samples of rivers, streams, and lakes to see if these animals exist. If they don't, that means something's happening to the water, making them dirty. And so these bioindicators can indicate whether or not the water is clean, hence the name. If water becomes too polluted, those animals won't survive. Scientists will take those samples of living things in rivers and find out what kinds of life is found there. Right? If water starts to get too polluted, you won't see these things. You'll actually see more worms, right? Because they're feeding on the dead bioindicators that used to be alive in there. And so these worms can be a sign of pollutants in the water. And so the government sets standards. How much of any one chemical can be found in rivers and streams? Scientists regularly test these waters to ensure these measures are met. Right? If a company, for example, a fertilizer manufacturer or even a farmer is using too much fertilizer or using too much chemicals, scientists will test the surrounding waters to ensure that they're not putting too many chemicals in the environment. If they do, the government will try and shut them down or fine them. And so governments use our understanding of water, the importance of water, as well as the ability to test water to control its cleanliness and, again, the survival of ecosystems in the environment. So hopefully you found this useful, and I'll see you next lesson.